Ladies and gentlemen of L2 Honors, welcome to class today. Good to have everybody here. Today we're going to be working on quadratic functions, and specifically, I don't know if you remember, about a weekend before last, I sent out via Remind a video of this problem right here, if it will come up. Here we go. Is it? No.
Okay, we're going to work this problem on the human cannonball right here, but before we do, I want to show you where I got this problem from. So let's go to the computer right now and take a look. So here's where I got the problem. I found this ad online, and it's an ad for David Smith Jr., the human cannonball, and he calls himself the Bullet, and he's going to be shot out of a cannon at a county fair. And look down here. It says he blasts into the air, flies an average distance of 160 feet, and a height of 60 to 70 feet, and lands in his pre-positioned safety net. So just with those two numbers, it turns out the 160 feet that he flies and the 70 feet he goes in the air, we can find the equation for his path just using algebra. So
basically this is the kind of problem we've been talking about. So we're going to go ahead and in second period class, for instance, we talked about this problem a little bit, kind of how you'd set it up, and you can see that basically we use the same vertex form of an equation and work through, and if we continued on the process, we would find the actual equation that produces that arc, which is what we're doing in these exercises today. And we come to problem 11 right here, okay, which is a soccer problem. Any soccer players in here? Benjamin, a soccer player, okay. Okay, we've got a soccer player who's 25 feet away. So I can start spinning the wheels right now, or do you want me to just go over this one?
go over.
So right now we have soccer players 27 feet away from a goal. So here we have a goal. So this would be a goal, and we have a soccer player here, 27 feet away. Here the ball is going to go in some kind of a path, and the ball reached a maximum height of 10 feet. So here we have 27 feet away. Feet away, and we have our maximum height of 10 right here. And when it was 15 feet away from the goal, so if we put 15 up here, that would do it for us. Now, how would we orient a coordinate plane around this to be able to work this problem out? How would you do it? By the way, there's not just one way to do it either. What would your suggestion be? Any ideas? So if Abigail says 15 equals h and 10 is equal to k, are you okay with that? Are you okay with that? If we do that, that really informs what our orientation is going to be of that, doesn't it? So if 15 is h and 10 is k, that means that this thing right here is what? That's our origin, right? And so that's the way to put it. That might be the easiest way to put it. I've also had students put it as, you can also put the vertex right here if you wanted to, but that complicates things. Or you could put the y-axis right here and make this 0, 10, but then you'd have to make this point -15, 0. So I kind of like the way Abigail set it up. I think that's going to be the easiest way to do it. But can you see there are different ways to fashion the problem? Okay, let's go on here. So we have our standard form equation, which is f of x is equal to ax minus h squared plus k. And we know what those are now, so we can put f of x is equal to a times x minus h, and if h is 15, that's what we have here, plus 10. Okay? What next on this thing?
Insert the other point.
And the other point is
27.8.
27.8?
Or 27.8.
Well, the thing about it is we know the goal height is 8 feet, but does that correspond necessarily with the flight of the ball?
No.
No, it doesn't. What is a known point?
0, 0.
So 0, 0, right? Here would be our known point. And yeah, we're going to use 27, but that's going to be like our test input. Okay? So let's use 0, 0. So we have 0 is equal to a times 0 minus 15 squared plus 10. So you can have 0 is equal to, what is 15 squared?
225.
225. 225 15 squared is one of the things that at some point it'd be nice to know. So now we have a is equal to negative 10 over 225. And can that be simplified? What is that simplified?
Oh.
2/45. Okay, so now do we have an equation we could work with?
Yes.
Yes, we do. So we have f of x is equal to negative 2/45. We have x minus 15 squared plus 10. And what can we do to find the answer to our question here? Find f of 27, right? Where do we find that? Right here. So I'm going to put negative 2/45. Over here we have x minus 15, what was it? And over here we're going to put plus 10. And there, what can we do now with this? Go to
Table.
Go to table view is what I would do. That's probably, so we go to table view, and we're going to test, what do you say, Ben, 27 feet? So at 15:10, does that work out? Yeah, so that's kind of a check. So here we are, 18/5, right? Which is the same as 3.6. 3.6 feet. So is that our answer? Yes. Question, will the ball go into the goal or go over it?
Into.
We would say yes, and then according to Telemundo, we would say what? Goal! Oh! Anybody watch Telemundo? They do it? Yeah. But, so you guys laughed a little bit at that. So, goal! And you guys that don't know that, you need to watch that. The guy calls the game. Well, he goes on like, how's the guy that hardly catches his breath? You know what I'm talking about, Addy?
Like 30 seconds at least.
Yeah, 30 seconds. He says, go! He just says it. Oh! All right. So some of you actually laughed at me a little bit today, so I appreciate that.
I laughed at the way you were like, oh, oh.
That's what he does. If you listen to him, that's what he does. Because he keeps on going, he just takes his breath. So I was kind of copying. Okay, here's what I want you to do. Work on number 12. I'll call on somebody for number 12 for assistance with that shortly. And to me, I don't think these problems are that hard, but it's drawing the picture, kind of conceptualizing where that goes. That's the challenge with these things. Oh, I didn't mean to spin the wheel.
Peyton.
No, Peyton, we'll take your name off the list, Peyton, because you did it right. No, because Peyton has been picked on a lot lately. So we already got you crossed off the list, Peyton.
Thank you, Steve.
I knew you'd appreciate that. By the way, I had two different answers on problem 12 earlier today. They were slightly different.
Where they both from?
One was right according to the book, and one wasn't right according to the book, but I still think it was right.
I struggle with drawing the pictures. I can't see it in my head.
Think of stock pond, okay? Stock pond is going to look like what? It tells you a parabola. Stock pond will look kind of like this. Look at that sideways, right? So we're told the stock pond has a parabolic shape.
Does it matter which one goes false?
What'd you say?
Does it matter which one goes false?
Yeah, I'm confused already, so don't be.
I don't know.
I don't think it does. You want me to help you with a picture on this? So here you have a pond. That is the parabolic shape of the pond. We know the pond is 8 feet deep. In the middle of the pond, it says pond is 24 feet in diameter. And so if you look at from the air, looking down, it's going to be a circle looking down, but cross-section wise, that's the shape of a parabola. Does anybody have a stock pond on their property? One does. You do? Okay, so this is right up your alley. So Peyton, we should have left your name in there. You should have been the expert on this.
I mean, you
Oh, that's good.
Let him do it.
So anyway, this is the pond. We know this is 24 feet in diameter. And so depending on how you look at this, you could call this point 12, -8, right?
Where'd you get?
It is half of the,
Okay, does that make sense? Okay. Now we'll spin the wheel. Here we go. Type J, all right, J. All right, Jay, what do we got here?
I got f of x equals a quantity x minus 12 squared minus 8.
Okay, is everybody okay with this representation so far? Okay, good. Let's go on. Go ahead, Jay. Thanks.
And I got -3 equals a quantity 22 minus 12 squared minus 8.
Where did you get this -3 and this 22?
The -3 because it said 3 foot away from, or 2 foot away from the shore is 3 foot deep. And the 22 because 24 minus 2 is 20.
So you're saying this point over here is 22 comma -3? Okay. Now we'll say that other people in the class used 2 comma -3, which is another possibility, but go ahead. I think you're going to be okay still. All right, let's go ahead.
And then we got -3 equals 100a minus 8.
Okay.
So I got a equals 120.
So we add,
Yes.
so we get 5,
Equals 100a.
100A. So A is equal to 1/20th.
Yes.
Okay, let's go ahead.
And then f of x equals 1/20th quantity x minus 12 squared minus 8.
Okay, and then,
That's as far as I got. But then you would have to go f of 6, right?
yeah. So let's do that in the calculator. So we're going to put in 1/20th. And what'd you say it was? X minus 12? 20x minus 12 squared minus 8. And then we test to see what we get here. We graph. We'll go to table view. And let's see if we got 22 -3. Did we get 22 -3? Yeah. Let's see if we got 12 -8. Do we have that? Yeah, we got it. And so we need to find 6 feet away. So there it is, right? So we would say, how deep is the pond at 0.6 feet 4? It is 6.2 feet deep, right? All right. Now the other answer that someone else got was, instead of using what Jay did, she used the point 0, 0. Because if the thing came right to the surface and intersected the surface evenly, we could use 0, 0 instead of 2, -3, right? But if you did, it's going to be different. I think it would be exactly 6 feet deep if you did that.
If you look at 0 on the table, you would not 0.
Yeah, Ben makes a good argument here. Because if you take, he says if you go to 0, 0, it doesn't put you exactly there. It puts you like 0.8 feet below surface.
I mean, like, even though the graph, it wasn't quite.
Oh, so you looked at the graph too? So let's go here to, we'll go 0 to 25. No, I'll go to -1. -1 to 25 here is what we'll do. And then go by ones. And then for y minimum, yeah, -8 would be just perfect, right? We'll go to 2, and we graph. This is what we see here. Is that what you're noticing, Ben? Right here like this? Yeah. But we see we have 2, -3, or as Jay said, we had 22, -3, and then we have 6, 1, 2, 3, 4, 5, 6, -6.2. So it all looks pretty good, right? Okay, that is some good work right there. All right, I want you to work on number 13. 13 is even a scant bit more challenging, so go work on 13, and we will just go to that point, maybe as far as we get. How's it going, Kim?
I don't understand.
You don't understand? Okay, this is a very much, anybody else having trouble understanding the sketch of it? A few of you? Yeah. Yeah, this one here was, when I first encountered this problem last year, I said, wow, this is hard to understand what's going on. So we got a roadway that's 40 feet wide. So here's our roadway, 40 feet. And then we have a bridge goes above a roadway on ground level. The main span of the bridge is 90 feet wide. So we have this bridge whose span is 90 feet. And it says, at the edge of the roadway, 25 feet from where the arch touches the ground, the arch is 16 feet high. So here, we have 16 feet right here, going right to here. The arch is, no, it's 25 feet, excuse me, I got it backwards. That's 25 feet. And this is 16 feet high here. So I'll say 25, comma 16. And then we want to find the height of the arch here. What do we know about the arch? About this top point of the arch?
The axis of symmetry is 45.
So 45, Ben says 45. So we don't know how high it is, but we know that that axis of symmetry is 45 feet away. So I'll put a question mark. And then this point right here is 0, 0.
Wait, which one was 0, 0?
Right here. We got a, so we got a coordinate plane like this right here.
And then your other point would be 0, 9. 90, 0, or on the other side.
Yeah, 90, 0 could be a point too, right? Yeah, so Bryce makes a good observation here, right? Now, we would use this point here and then one of these two. 0, 0 and 90, 0 give us the same thing. Or they will. So what would an equation, how do we write an equation to analyze all this? I'm going to do something here. That is to hand out some classwork here. And I want you to look at problems 7 through 10. Okay, is 7 through 10 helpful at all here? Yes. So may I spin the wheel?
Yeah.
You've got to spin the wheel. Okay, we'll spin the wheel. Okay, here it is. We know it's not going to be Jay. We know it's not going to be Peyton.
No, I can't do it.
We know, we know it's going to be Ben. How many of you are happy that Ben got picked on? All right, Ben, help us out.
Okay, so the first equation is 0 equals a parentheses x, sorry, 0 minus 45 squared plus k.
Okay?
Then below it, the other equation is 16 equals A parentheses 25 minus 45 squared plus 4.
Okay.
And then you subtract 1 from, oh no, then you simplify first.
Simplify first. Okay, let's simplify first. We get 0 equals,
Yeah, that big number right there.
and we have 16 equals 400A. Okay, then
You
subtract.
would be negative 16 equals 1,000. Six, yeah.
Okay, so A is equal to, is that right?
Yeah.
So what next?
You insert negative 16 over 1625 as A.
Okay, so f of x is equal to negative 16 over 1625. And that's going to be x
Squared plus K.
Okay, and then what?
You get a point, so I guess you do 0, 0, 0, 0.
Well, here, what we can do is we can take this and plug it back in for one of these, right? So let's do that. You want to do this one here? So 0 equals 2025. Then we're going to put negative 16 over 20
No, over 1625.
over 16. Oh, 1625, thank you. Yeah, I'm getting the numbers mixed up. That's going to be plus K, right? So basically, it'll be positive this, right? Because we're the other side. So 2025 times 16 over 1625, right?
It will be negative,
So 19.94, right?
It wouldn't be negative 19?
No, it'll be positive because we have to add, right? So this negative becomes positive over here. So this is our height. Now, as it turns out, in second period, we got a number that was less than 16. Well, why is K not going to be less than 16?
because we already have a point of that 16.
Because we got to have a higher point. So I'm not sure how we got that in second period, but that is right. So we'll just call it, probably tomorrow we'll resume on problem 14, just sort of leave it there, all right? Thank you. What's that?